Welcome to all of you. My name is Akhilesh and I'm your facilitator for geography as we are going through this crash course for mains examination. So you all have this idea that the real exam for civil service is your mains examination, where your writing skill is going to be tested. And writing skill comes to you once you have the better understanding of the concept. So today we are going to start the geography part. Let's begin. Out of the entire syllabus, because there will be less time, so I have chosen some very important topic which can be a potential question in your examination. So I will go in detailed study. Apart from it, I will give some question upon it so that you can write. And I will also ensure that the questions looks alike, but their demand is little bit different. Because sometimes UPSC has a language in which you get stuck and you carried away by the keywords only. But the real demand is not met. So in this session, 5-6 classes will be there. So I would like to give you some question which looks alike, as if the demand is same, but the requirement different. So that will also be the part of my discussion. Further, whatever the question I will provide you in the class after discussion, please do write and follow the discipline also, because you are going to have almost 7 minutes to write the answer. So when I give you question, go to home and आपकी तरफ से ऑनेस्टी वो आनी चाहिए. आपका स्टॉप वॉच शुरू करें और क्वेश्चन को समझें, फिर उसके बाद लिखने का जो टाइम आपका होना चाहिए, दैट शुड नॉट बी exceeding 7 minutes. As in GS class, I usually go for practicing map. So many map I usually draw so that you have the ability to draw it within 10 seconds, not more than that. Whether it is map of India or it is world map, because presentation makes your question answer at next level. You are going to have some extra marks for your presentation skill. And especially for geography, if you are putting certain map in your answer, it is going to be helpful for always. Fine. You all have this idea that answer include introduction, there will be main body and then conclusion. So it should always be followed. There should be introduction. Again, you face problem to write introduction, what to write. And you start writing whatever the keyword is there in question. But I always suggest that you should introduce the demand of the question. Okay? So your introduction must succinct with the demand. It is not like a keyword is there, some context, statement is there, you are writing, you start writing with that. Your introduction, जैसे मैं पूछूं आपसे कि आपका नाम क्या है, the question is what is your name. So your answer is आप अपना नाम बताएंगे. If I ask what is the meaning of your name, तब भी क्या आंसर वही रहेगा. Are you getting my point? What I mean to say? So your introduction part is going to be different. When you start discussing what is the meaning of your name, आप वैसे ही आंसर नहीं दोगे, है ना? तो ये जरूरी होता है, यूपीएससी ने पूछा क्या, and accordingly you start introducing. So introduce the demand of the question, because introduction must contain the glimpse of the entire demand. और यूं कह लीजिए कि मूवी का ट्रेलर होता है इंट्रोडक्शन. मूवी में जो बहुत इंपॉर्टेंट पार्ट्स है ना, ट्रेलर देख के आपको अंदाजा लग जाता है कि ये मूवी किस सब्जेक्ट पे बनी होगी, कौन हीरो है, कौन से इसके इंपॉर्टेंट डायलॉग्स हैं, तो कुछ ना कुछ आपको उस ट्रेलर में मिल जाता है. सो दिस इज समथिंग फॉर इंट्रोडक्शन. इज इट ओके? So there should be introduction, and your introduction should not be too long because sometime you happen to have 150 words or 200 words. तो बहुत लंबा इंट्रोडक्शन भी नहीं होना चाहिए और कंक्लूजन भी लंबा नहीं होना चाहिए, and there will be main body. So introduction must succinct with the demand. Don't get carried away by certain keywords. होता क्या है कि अगर मैंने आपसे पूछा all the deserts are located at western margin of the continent, what are the condition prevailing over there, then you start writing what is desert, na ki scanty rainfall, less than 25% rainfall and all. It is not the demand. If they have asked what is desert, then you introduce it, it's okay. लेकिन हर जगह आप desert की बताएं, पूछ ये रहा है कि what are the condition prevailing over there that is resulting desertification, and you are putting the effort to describe the desert, isn't it? Is it the trailer of the movie? Answer is no. ठीक है, तो मेरा कहना है इंट्रोडक्शन लिखते समय आपको थोड़ी संजीदगी का परिचय देना चाहिए, और इंट्रोडक्शन हमेशा क्वेश्चन में जो निहित डिमांड है उसका होना चाहिए. ठीक है, इसकी भी हम लोग प्रैक्टिस कर लेंगे, और आपसे मैं चाहूंगा आप आंसर लिखें और क्लास के बाद मुझसे इवेलुएट कराएं. ठीक है, यहीं बैठेंगे हम लोग क्लास के बाद, एंड ब्रिंग ऑल दोज आंसर वी विल डिस्कस जो क्लास के हैं. और अगर आप पीवाईक्यू भी डिस्कस कर रहे हैं, आप उसको भी लिख रहे हैं, तो यू आर इनवाइटेड, और हमेशा मैं आपके साथ रहूंगा. तो चलिए आज शुरू करते हैं. एंड जियोमॉर्फोलॉजी में जो मुझे लगता है पहला टॉपिक जो आपसे जिस पे क्वेश्चन बन सकता है वो है इंटीरियर ऑफ द अर्थ, isn't it? So they may put the question on interior of the earth. In the classroom, we have discussed the interior of the earth is a deduced model based on certain observation. So on the basis of observation, we happen to construct the model of interior of earth, and for that we have direct sources, and they are limited. Direct sources are very limited, and then we have indirect sources. क्लास में भी मैंने बताया था, डायरेक्ट सोर्सेज में जहां तक हमारी पहुंच है वो मुश्किल से 12 किलोमीटर की गहराई है, इफ यू रिमेंबर द क्लास. और आप जानते भी हैं 12 किलोमीटर इज द मैक्सिमम डेप्थ अप टू विच ह्यूमन हैव रीच्ड पोलर रीजन डीप ओशन ड्रिलिंग प्रोजेक्ट. ओके, so we have very less direct source which is going to give some idea about the interior of earth. That's why we explore some indirect source. I usually say gem spot, ना, जो अर्थ के अंदर जाए और बाहर आके कहानी भी बताए. तो उसके लिए हम लोगों ने क्या चुना? वी चूज seismic waves. Okay, again the seismic wave itself is going to be important. Do remember, it is also important. You can get a potential question from seismic wave also. Okay, seismic waves, and on the basis of observation of these seismic waves recorded by various seismographs that were the shadow zone of S wave and shadow zone of P wave, we are able to deduce the model, deduced model of Earth's interior. So basically our focus will be here, क्योंकि मुझे लगता है इस पे काफी दिन से सवाल नहीं आए हैं, तो यहां से सवाल बन सकता है. एस वेव, पी वेव, शैडो जोन. So we must have the understanding in detail. Let's find out the seismic wave first, their characteristics, then we will go for shadow zone. Is there any confusion in front of you? You have the idea of seismic wave? Okay, let me give you some tidbits about seismic wave. So seismic waves, this is your earth. suppose that this is the point at which there is some seismic activity have taken place, huge amount of energy released, and it is called as hypocenter. It is called as hypocenter or focus of the earthquake. And from here, energy start traveling and it reaches onto the earth's surface, and the place is called as epicenter. Okay. And the energy which is released inside the earth travel in form of which wave? बताइए. Body waves. ना, ये कौन सी वेव्स हैं बच्चे? दे आर, सुबह सुबह क्या नींद में है क्या आप लोग अभी? Body waves. Fine. These are body waves. Why they have been called as body wave? Because they travel inside the body of the earth. Is it okay? And this body wave is of two types. One is primary wave and another one is secondary wave. Fine. Body wave is of two types. One is primary wave, another one is secondary wave. These body wave bring the energy on the surface, and this energy get redistributed. And after redistribution, there is genesis of surface wave. So, here what happened? A redistribution of energy. Redistribution of energy taking place. Okay, and that's why what happened? There is genesis of surface wave. यहाँ से surface wave बनते हैं बच्चे, और that start traveling in the skin of the earth. They are surface wave. Fine. Surface wave, again it is of two type. That is what? L wave as well as R wave. इसकी कहानी आप जानते होंगे. AEH Love discovered this love wave and Rayleigh discovered R wave. Surface wave are the disastrous wave. They are inflicting most of the disaster due to earthquake. Fine. लेकिन इंटीरियर ऑफ अर्थ के पर्सपेक्टिव में अगर देखा जाए तो सरफेस वेव इज नॉट गोइंग टू गिव अस सम tidbits. It is the body wave which is traveling inside the body. That's why it has certain observation. So, in order to understand those observations, we have to understand the characteristics of these body waves. So, let's find out the characteristics and which characteristic have given us the idea of interior of Earth. Let's find it out. So, first one is primary wave. ये नोट करते चल रहे हैं, डिक्टेशन का तो चक्कर नहीं हो सकता, बहुत कम टाइम है बच्चे, इसलिए, बट हाँ कुछ बातें जो आपको एक्स्ट्रा मिले उसे जरूर नोट करिएगा. प्राइमरी वेव, एंड आई एम श्योर कि यू विल गेट समथिंग एक्स्ट्रा. सो प्राइमरी वेव दे आर ऑल्सो कॉल्ड एज, क्या कहते हैं इसको? पी वेव. माय फर्स्ट क्वेश्चन इज व्हाई इट इज कॉल्ड एज पी वेव? First to arrive. That is the reason of primary wave. Why it is called as P wave? क्या पढ़ा है आपने? पढ़ा? हाँ? You can't answer. Okay, fine. Why it is called as P wave? This is the question. Because of primary. Most of you have the perception P for primary, hence it is P. The answer is wrong. Why it is called as P wave, I will discuss later. But yes, it is the fastest wave. Fastest wave. First to reach at epicenter. Fastest, that means how fastest? 6 to 15 kilometer per सेकेंड कि पर आवर? पर सेकेंड। पर आवर होता तो फिर प्रॉब्लम ही क्या थी? अर्थक्वेक साइकिल पे बैठ के आ रहा है ना? सो इट इज व्हाट? पर सेकेंड. फाइन. सो फर्स्ट टू रीच at epicenter. First to reach at epicenter. It is a mechanical longitudinal wave. Mechanical longitudinal wave, that means what is mechanical waves? Mechanical waves are those waves, they require medium particle that oscillate. Now, and longitudinal mechanical waves in which the medium particle oscillate along the direction of wave propagation. Along the direction of wave propagation. If this is the wave propagation direction, so medium particle oscillates like compression, rarefaction, compression, rarefaction. That means to and fro from its mid position. So this is the oscillation. Okay. So longitudinal wave, the medium particle oscillates along the direction of wave propagation. Is it okay? Mechanical longitudinal wave. Just like sound wave. For example, sound wave. Okay? Just like sound wave. So P waves, our primary waves, are just like the sound wave. So have you heard earthquake? Earthquake जब आता है तो you have heard the sound. Whenever any earthquake is there, you will find rumbling sound inside the ground, as if there is a huge motor is moving inside the ground below your legs. And that is what the sound of rumbling sound is actually the arrival of P wave. Arrival of primary wave. Okay, so the sound produced at the time of earthquake is because of arrival of P wave. Rumbling sound. It is the arrival of P wave. जमीन के अंदर जैसे लगता है बहुत बड़ी मोटर. A motor is moving inside the earth surface. That is what primary wave have arrived over there, bringing the energy that is going to generate surface wave. Fine. Okay, mechanical longitudinal wave. Further, this primary wave are intrinsically, their nature is to create pressure. They are push waves. Push waves are pressure creating waves. Push waves are pressure creating waves. They are push wave. जैसे मैं बोल रहा हूं ना, so my voice is going to create pressure on your tympanum membrane. Then tympanum membrane is going to vibrate according to the, what you can say, modulation of voice. Accordingly, your tympanum membrane is going to vibrate, and that vibration is already fixed in your mind that in which language I am talking and what I am talking. So this sound wave is what? Pressure creating wave. That's why you heard. Similarly, the primary waves are pressure creating wave. That's why we hear the sound. That's why it is bringing lot of energy. And this is the reason why it is called as P wave. So P wave is its intrinsic nature. It is going to create push. It is going to create pressure. It is not the primary, that's why P wave. It is push creating wave, pressure creating wave, that's why we call it P wave. So do remember. Further, this wave can travel, it can travel in solid, liquid and gas. That means it can pass through all medium. It can pass through all medium. Do remember this characteristics. It can pass through all medium, but the velocity of P wave get increased when there is increase in the medium density. Sound wave को आप जानते हैं ना? What is the speed of sound wave in air? 332 meter per second, isn't it? And what is the sound wave speed in steel? 1150 meter per second. So what happened? Air density and steel density. Density has massively increased. So what happened? The sound wave speed is also increased. Is it okay? So next point you can take down that density of, if the density of medium increases, velocity also get increased. Velocity of P wave also get increased. अच्छा, जब वेलोसिटी इंक्रीज करता है बच्चे तो अपना जो ओरिजिनल पाथ है उससे वो डिफ्लेक्ट हो जाती है. सो व्हेन देयर इज अ इंक्रीज इन वेलोसिटी, द पाथ ऑफ द P wave get deflected from its original path. Is it okay? When there is increase in velocity, when there is increase in velocity, the P waves get deflected. P waves get deflected. इसने बहुत बड़ा रोल प्ले किया बच्चे, शैडो जोन जो बने उसको समझने में. इज इट ओके? सो P wave get deflected because of increase in density. Increase in density increase the velocity, hence the original path of P wave is not going to be followed. It will start executing some other path. That's why there is deviations. I will tell you the deviation. Let's come to the secondary waves. Secondary waves. Why they have been given the name secondary? Because they are second to reach at epicenter. अब क्यों सेकंड आए? क्योंकि धीरे दौड़ रहे थे. दे आर स्लो मूवर्स ना, सो दे हैव लोअर स्पीड. Lower speed, they are second fastest seismic wave. They have a speed of 5 to 7 kilometer per second. This much speed they are going to have. That's why they are second to reach at epicenter. Is it okay? They are also called as what? S wave. Again my question, why they are called as S wave? Obviously you are not going to tell, na? The same story. So anyone who can tell me why it is called as S wave, secondary wave is called as S wave? आप बताइए. No idea? It can pass to medium, only solid medium. That's why it is called as S wave. Solid का S आ गया? No, not like that. Intrinsic nature, the nature of the wave. I'm just explaining it. Please do remember and mark it important because it is not given in your NCERT. So you will also get the answer why secondary waves are not able to cross liquid medium from their virtue, ना? अभी बताऊंगा इसके बारे में. वेट फॉर इट. और क्या है बच्चे? इट इज मैकेनिकल ट्रांसवर्स वेव. इट इज मैकेनिकल ट्रांसवर्स वेव. देखिए, जस्ट लाइक मैकेनिकल ट्रांसवर्स वेव. क्या होते हैं बच्चे मैकेनिकल ट्रांसवर्स वेव? ऑसिलेशन ऑफ मीडियम पार्टिकल टेक्स प्लेस परपेंडिकुलर इन द डायरेक्शन ऑफ propagation of wave. This is the wave propagating and the medium particles are oscillating like up and down. So perpendicular to the direction of wave propagation. This is direction of wave propagation, and you will find that this medium particle is oscillating perpendicular to it. Such mechanical waves are termed as transverse wave. For example, if you take the general example, the surface wave in the water. If you throw a stone inside the water, ripples will be created and ripples start traveling towards the coast. So on the surface, if you watch the water at the surface, means if this is going to be water and you are throwing the stone over here, and then what happened? Ripples created and it start moving towards the coast. This is the ripple. So once you see the surface, you will find that the medium particle is oscillating perpendicular to the direction of propagation. So this is what? As surface wave. So it is just like the ripples, water moving towards coast, when you throw a stone over here. So surface. But अगर अंदर देखा जाए तो सुनामी मैंने आपको पढ़ाया है, आपको पता है there is a circular motion, complete circular motion is taking place. But at the surface, if you see the water, it is just moving at same place and the wave is moving. The energy is moving in form of transverse wave. Is it okay? Fine. Further, secondary waves can travel only in solid medium. Only in solid medium. तो पूछा गया भाई क्यों? तो secondary wave said कि we are shear producing wave. Our intrinsic property is to produce shear. That means a force which is tangentially acting upon the body and creating some deformity. जैसे आपको एक kneaded floor दे दिया जाए, आटा दे दिया जाए, and you just punch inside it, what happens? There will be deformity that is going to be created, isn't it? If you punch on this wall, what happened? There will be deformity created in your punch, no? Are you getting my point? So, what is the meaning of shear? A force which is tangentially acting upon the body and intended to create deformity. This is called as shear. So, secondary waves are shear producing wave. Secondary waves, please note it down. Secondary waves are shear producing. Shear producing wave. That means it try to produce shear. This is solid medium, and this secondary wave is coming over here like this. Here it is secondary wave, and if this solid medium is there, what happen? It will try to produce shear, but shear is not results deformity. That means energy is conserved. Then energy conserved, that's why this wave travel through solid medium. This is solid medium. It is a shear producing wave. Shear producing wave. And this is going to be solid medium. Shear is not going to result deformity. So what happened? Whatever the energy is here, it is going to be conserved. So wave travel through solid medium. Is it okay? Fine. Now suppose that there is a liquid medium. This is the liquid medium. Okay. And this is the secondary wave that is coming over here. As you know, it is a shear producing wave, so it will try to produce shear, and the liquid medium get displaced, isn't it? Liquid medium get displaced under the influence of the force exerted by the wave. That means in liquid medium, shear can create deformity. And if deformity is created, so what happened to the energy of this wave? It is going to be dissipated. Dissipated to create deformity. So when it strikes to the liquid medium, what happened? There is a deformity created. This is a kind of displacement. This is what? Deformity. Deformity. So this shear producing wave intended to produce shear, liquid medium get displaced to create deformity. So what happened to this energy? The energy which is associated with it is going to be dissipated in creating deformity. तो यहां इसके बाद क्या करेंगे? They cease to travel. They cease to travel. This is the reason why secondary waves are not able to travel in liquid medium, because they are shear producing wave and they intended to produce shear and that turn into deformity. ठीक वैसे ही कि मैं आपसे कहूं कि मेरे पेट पे पंच मारो. You just punch me here. You punch me, I will be in hospital. Isn't it? And if I say कि let me put that very dug Ashirwad atta and I keep it here and then I say to Mike Tyson, come on, punch me. So what will be the impact? He will punch me, there will be deformity and I will say ha ha ha. Are you getting my point? This is the meaning that shear producing wave, if producing deformity, then entire energy is going to be seized, dissipated. This is the reason why they are not able to travel in liquid. अब समझ में आया why it is called as S wave? Why? Shear producing wave. So S wave, this S stand for shear producing wave. So now we have the understanding of the characteristics of our James Bond, and let's find out the story what the James Bond have given to us. And the story is what? S wave shadow zone as well as P wave shadow zone. Why it was chosen? Because this is the only thing which is traveling inside the interior of the earth, and we are knowing the characteristics, how much density is going to change, how much velocity, and we have the time traveled and the distance traveled. On the very basis of so many computation, calculation, data analysis obtained from lakhs of earthquakes every year, we zero in that how the interior will look like. Then the observations by the seismograph was pivotal to understand the interior of the earth. And what were the major observations जो आपके GS में है? That is shadow zone. Let's come to the shadow zone. Shadow zone. Okay. So two shadow zones were discovered. Let me explain it. This is the hypocenter. What is the meaning of hypocenter? Focus of the earthquake from where the seismic energy is being released. And here it is the center of the earth. Just इन दोनों को मिला लेते हैं. This is a line. This give you 90-degree angle, isn't it? Okay. There is an angle of 103 degree and 143 degree. 103 and 143. So this angle is with respect to center of the earth and hypocenter. Do remember, this is what? Hypocenter. Okay. So for each and every seismic event, P wave and S wave start traveling in all sides, and it is being recorded on the surface of the earth by the seismograph. Is it okay to everyone? भाई seismograph दुनिया भर में इतने सारे कंट्री हैं, सबके मेट्रोलॉजिकल स्टेशंस होंगे, एयरपोर्ट्स होंगे, एंड देयर आर इनबिल्ट seismograph. So these seismograph is going to record the P wave and S wave over here, and they start traveling to all sides. So let's take up this. I'm talking about P waves. Now P waves were recorded everywhere. Everywhere it were recorded. But strikingly, these P waves were not recorded beyond 103 degree. On entire globe, it is not recorded on beyond 103 degree. But again, they are being recorded beyond 143 degree. That means this zone is not shadow zone. Only 103 to 143 is going to be P wave shadow zone. P wave shadow zone. This is the part which is what? P wave shadow zone. Between 103 to 143 degree. In your book, it may be 105, there will be 145, hardly matter. But the P wave shadow zone is have a deviation of almost 40 degree. Is it okay? So, this is earthquake event E1. Suppose that there is another earthquake event that is taking place, and that is E2, and the place hypocenter is here. Is it okay? ये भी तो हो सकता है. This is hypocenter, so here it is center. This is going to be 90 degree. What about 103? This is 103. Here it is 143. And this way it is 103, 143. ये इसलिए बता रहा हूं ना बच्चे, बच्चों को ऑप्शनल में बता दो, उनको ये एंगल का आता पता नहीं रहता, उनको ये लॉन्गिट्यूड दिख रहा होता है. It is not the longitude, it is an angle with respect to the hypocenter. Do remember. Okay. So, in this case, again, P wave start travel to all sides. It is traveling like this, but beyond 103 degree, again, the same result were there, and it is not observed between 103 to 143 degree. Again, beyond 143 degree, P waves were recorded. So, we are again getting this P wave shadow zone, which is showing the deviation of almost 40 degree. And this P wave shadow zone was consistent in deviation. It is consistent in all the seismic event, isn't it? तो पूछना तो पड़ेगा कि consistent अगर results आ रहे हैं तो there is something. When P wave were analyzed, कि why you are deviating this much, so they have a characteristic that they can travel in all the medium, but they have also a characteristic on increasing the density, their velocity is on increase. And this much 40 degree deviation was concluded that there is something at 2900 kilometer from the Earth's surface. Kitna? There is something 2900 kilometer from the Earth's surface. There is enormous change in density. Change in density. There is enormous change in density, and due to change in density, what happened? There is change in velocity, and the velocity change is rapid. मतलब बहुत ज़्यादा velocity change हुई, and due to this change, what happened? There was deviation, and this deviation always going to be 40 degree. So there is something present below 2900 kilometer. Is it okay? So what was the thing which is present below 2900 kilometer over here, like this, and it is so dense that the P waves get deviated. P waves get deviated. P waves आना चाहते थे बेचारे, ऐसे आ रहे थे, देखो, they try to come like this and they want to reach over there, but they get deviated. They get deviated. So they are not being recorded between this zone and they are being recorded beyond it. That means the P wave shadow zone is giving you the idea that below 2900 kilometer there is very high density, and they have given you the idea of core which is made up of iron and nickel. Is it okay? I will tell you the change in density. If you see the mantle, you have the density of 3.5 to 5.5 gram per cc. This is the density change while we are moving in mantle. As you reach to outer core, the density is 10.5 gram to 11.5 gram per cc. This is a change. Try to see, if you take the upper limit, there is a double change in the density. Are you getting my point? And due to this, what is there? Deviation of P wave by 40 degree. So this P wave shadow zone is decisive in understanding that the core is of very high density. Is it okay? समझ गए आप? Try to understand the concept. क्या लिखना है? If you go for this, making the P wave shadow zone and making these points over there, certainly you will get good marks. You can see that I am just putting a lot of figure to make you understand the things. If you reciprocate in your examination, certainly you will get good marks. Is it okay? Further, and this is how here also we have the idea of core. So this gave the idea of core which is of very high density, and this also gave the idea of what? At which depth the core is present, because the consistency in the P wave shadow zone. Is it okay? Then there is S wave shadow zone. S wave shadow zone. S wave shadow zone. Again, we have the same understanding that there will be earth, there will be hypocenter, and there is center. Just here it is 90 degree, 103, 103. Okay. So this 103 degree is the angle with respect to hypocenter or focus of the earth. Fine. So you know that S waves also start traveling in all sides. It is recorded everywhere. It is recorded everywhere. But they cease to be recorded beyond 103 degree. Beyond 103 degree. This entire area is called as S wave shadow zone. This entire area is called as S wave shadow zone. तो obvious सी बात है, पूछा जाएगा कि भाई ऐसा क्या हुआ? What happened? Then S wave has a characteristic that they can cross only solid medium. So they said beyond 103 they are not coming. That means somewhere near 2900 kilometer there is medium. There is a medium which is liquid in nature. Liquid in nature, and this S wave shadow zone gave us idea about outer core. Outer core. Okay, so there is presence of outer core. कहाँ पे है बच्चे outer core? Somewhere 2900 degree, 2900 kilometer below the Earth's surface, and the center occupied by core. And the interesting part of outer core is what? It is liquid in nature. It is liquid in nature. This is the outer core. It is liquid in nature. तो क्या हुआ होगा बच्चे, एस वेव विल कम ओवर हियर, आए होंगे माइक टाइसन के पंच की तरह, क्या हुआ होगा, डिफॉर्म, energy associated with S wave get dissipated in the outer core region. That's why they are not able to travel, and that's why you have S wave shadow zone. So what will be the conclusion? कि there is something at the depth. ये depth का कैसे पता चला, 103. This is the angular distance, always going to be associated. Okay, and why the medium? Because you know their characteristic, they can travel only in solid medium. Okay, and it is outer core. So this is the observation which is in your general study. Obviously there were many more observations that have led to discovering the discontinuities, their exact depth, their density. Further, temperature was also deduced on the basis of tomographical scan. So on the very basis of these observations, ultimately the interior of the earth was deduced. It is a model that is deduced on the basis of observation and various calculation. How many calculation? Every year you happen to have more than 1 lakh of earthquakes. हर साल आते हैं बच्चे. 1 lakh earthquake has 1 lakh event that is having such kind of observation. So you can trace any and every observation and you can go for further reconstruction and then you find out the interior of earth. So these two things are there in your GS. That's why I'm not explaining some more thing, but do remember these are the basic requirement, basic observation. There are many more things which were observed. तभी तो आपको मोहो डिसकंटिन्यूटी, रैपिटी डिसकंटिन्यूटी, कोनार्ड डिसकंटिन्यूटी, लेहमैन डिसकंटिन्यूटी, गुटेनबर्ग, ये सारे मिले. तो ये डिसकंटिन्यूटीज कैसे मिले बच्चे? यू नो द स्पीड ऑफ द वेव एंड यू नो द degree of increase of wave with respect to density, and you know the time travel. So when you have all these data for 1 lakh replicate, so you can conclude it by using computers. It was analyzed and ultimately what was reached, the deduced model of interior जो मैं आपको बताने जा रहा हूँ. So mark it important, P wave S wave दोनों important है and extensively deal with it. अगर पूछ देता है तो shear producing wave और pressure producing wave जरूर लिखना, क्योंकि it is the punch of the concept. Further, P wave, S wave, shadow zone के significance क्या हैं? That can also be a possible question. इससे question क्या क्या बन सकते हैं अभी तक जो डिस्कस किया? First question will be like discuss the P wave and S wave, discuss the body waves. ऐसा सवाल बन सकता है. Then second question, significance of shadow zone in determining the Earth's interior. ये सवाल बन सकता है कि नहीं, है ना? What do you mean by shadow zones? shadow zone लिख लीजिए ये क्वेश्चन. क्या पता यही मां सरस्वती का कमाल हो जाए, कभी कभी सवाल सीधे सीधे आ जाते, है ना? मैं पुराना पेपर गेसर हूं, पुरानी आदत है. प्रीलिम्स में आपको कितने क्वेश्चन मिले इस बार? मिल गए? सीधे नोट से थे कि नहीं? ऑल द क्वेश्चंस इन योर प्रीलिम्स. नॉर्थ सी डिस्कस किया था, बोला था बॉर्डर देख के जाना. हाइट ऑफ ट्रोपोपॉज, कन्वेक्शनल करंट, कोरियोलिस फोर्स, देन वी हैव डिस्ट्रीब्यूशन ऑफ water vapor. This was also the question. So many questions directly from the notes. और मैंने कहा था, शुरू में नहीं कहा था, शुरू में तो मैं कहता हूं किताबें पढ़ो फिर मेरे नोट्स पढ़ो, लेकिन जब नोट्स बनवा लेता हूं, आपसे किताबें पढ़वा लेता हूं और जब मैं जान जाता हूं आपने किताबें पढ़ ली है, तब कहता हूं कि notes are capable enough to solve all your queries. लेकिन initially I never go for that कि मेरे notes sufficient हैं. Notes कब sufficient होते हैं? When you read the books. Are you getting it? तब देखना वही notes फिर तुम्हारे लिए ब्रह्मास्त्र हो जाएंगे. वो notes है ना बच्चे, इसलिए go for the reading, book reading, authentic book, NCERT, GC ले आओ for geography. And 1 A+, enough. And rest of the work I will do for you, collecting the current affair part from geography, and you are down to earth. These things, leave it up to me. So in the class, I usually go for current affair part in a way that it is going to give you the filler material for climate change, biodiversity, that means for your environment and ecology, disaster management, as well as geography. Because they are putting question which has an integral approach, isn't it? So you must have a kaleidoscopic vision, not only for geography. Basically geography, environment, disaster management, they are integral. आप टीचर अलग अलग होते हैं, but they are what? Integrated with each other. ठीक है? And if you see the questions, especially from environment, they are linked with geography. Like last year question, the climate change is going to affect the food security in tropical country. How the climate change is going to affect. So food security in tropical country and climate change, it is amalgamation of both the understanding. If you have the understanding of erratic rainfall pattern, extreme weather condition due to climate change, then you can put it with agriculture. So what is required is connectivity. If you are well connected with all your topic in your GS, then you are able to write beautiful answer, because it requires synthesis at that very time. Or synthesis only can be done once you have a kaleidoscopic vision. You can interconnect the subject. Is it okay? Fine. So there will be a question, what do you mean by shadow zone, and how they are useful in determining the Earth's interior. ठीक है, ये सवाल आ सकते हैं. तीसरा ये पूछ सकता है बच्चे, describe the body waves and observations that prove to be pivotal in deducing the model of Earth's interior. The model of Earth's interior. Question 1, question 2 and question 3. अब मुझे ये बताओ, क्या इंट्रोडक्शन सेम जाएगा? आंसर है नहीं. इट इज ऑलवेज फॉलोइंग द लैंग्वेज ऑफ द डिमांड. ना डिमांड क्या है? एक जगह डिस्क्राइब करना है बॉडी वेव्स, एक जगह कह रहा है व्हाट डू यू मीन बाय शैडो जोन, एक जगह कह रहा है सिग्निफिकेंस ऑफ शैडो जोन. सो क्या तीनों के इंट्रोडक्शन सेम होंगे? नहीं होंगे ना. ट्राई करोगे, कल लिख के लाओगे? लिख के लाओ. कितने वर्ड्स में लिखोगे बताओ? 200 या 150? देखो, अगर 150 है तो इट इज मोर चैलेंजिंग, क्योंकि यू आर नोइंग लॉट ऑफ थिंग्स. तो चैलेंज ज्यादा एक्सेप्ट करना चाहते हो कि हल्का वाला? सारे ऑप्शन हैं. 250 भी दे दूं, 200 भी, 150 भी. कौन सा मध्य मार्ग? महात्मा बुद्ध. चलो 200 words. So give me the answer in 200 words, and I appreciate if you put all those figure which is required. And the time is 7 minutes. घर जाना, समझ लेना, then sit and start writing with time and try to follow कि कितना लिख पाया और उतना लिख पाए कि नहीं जितनी जरूरत है. ठीक है, करेंगे आप लोग? करिएगा और कल ले आइएगा. सो आई विल ब्रिंग द अंडरस्टैंडिंग, जो आप समझे और आप लिख पाए कि नहीं. ठीक है, चले आगे. लेट्स कम टू द मॉडल ऑफ अर्थ, इंटीरियर ऑफ अर्थ. So on the very basis of these observation and so many data, computation data, we have found that Earth has major three layer, and that is what? There is crust, there is mantle, there is outer core, and there is core. Okay, crust, mantle and core, outer core and inner core. Further, we divide the crust into upper crust, lower crust, and there is a plastic layer in between crust and mantle. The upper part of this mantle, little bit upper mantle, is part of crust, that is collectively called as lithosphere. Okay, so this much is called as lithosphere. ठीक है बच्चे, लिथोस्फीयर जिसको आप प्लेट कहते हैं. टूजो विल्सन ने बताया कि इसे प्लेट कहते हैं. भाई प्लेट टेक्टोनिक्स पढ़ा है आपने. सो दिस इज व्हाट लिथोस्फीयर, दैट इज कॉल्ड एज प्लेट. देन वी हैव अ प्लास्टिक लेयर ओवर हियर, दैट इज कॉल्ड एज एस्थेनोस्फीयर. एस्थेनोस्फीयर. Okay, this is asthenosphere. Asthenosphere is called as powerhouse of Earth. Na? Powerhouse of Earth. It is the region from where all the energy, endogenic force are generated, and that is responsible for all the tectonic movement, volcanic eruption, earthquake, plutonic rock formation, isn't it? Formation of folded mountain and a number of geophysical phenomena that is taking place on the Earth's surface. That's why it is called as powerhouse of Earth. Powerhouse of Earth. ठीक है बच्चे. Then beyond this asthenosphere, this is actually the part of upper mantle, na? Upper mantle, and we have lower mantle. Then we have outer core, which is liquid in nature. Then we have core, which is solid in nature. So this is what overall interior. I am going to give you the detailed description of this interior. Okay, so that whatever the figure I am going to draw here is going to be the entire concept of interior. आपको कुछ और देखने की जरूरत आज के बाद नहीं पड़ेगी. बट हाँ, एक पूरे पेज में ये फिगर बनेगा. And be patient. पूरा एक पेज छोड़िए and let's come to the detailed description of crust, isn't it? चलिए आइए. So there is a crust that is called as upper crust and lower crust. This is the crust you will find on the Earth's surface. The Earth's surface is made up of this crust, and this crust can be divided into two parts, the upper crust as well as the lower crust. Upper crust is made up of silica and aluminium. This is upper crust, and here it is lower crust. Try to see why I made this kind of crust, because to differentiate that we have another type of crust, मतलब same type ही है, जिसको हम classify करते हैं as a oceanic crust as well as continental crust. Here it is oceanic crust, and this is what? Continental crust. Is it okay? And this is going to be upper crust. Here it is going to be lower crust. Is there any issue? अच्छा, मैं आपसे पूछूं कि oceanic crust is thicker or continental crust is thicker? देख के क्या लग रहा है? विच वन इज थिकर, देख के बताओ ना, यू अंडरस्टैंड मी, विच वन इज थिकर? कॉन्टिनेंटल, फाइन। कॉन्टिनेंटल क्रस्ट, एवरेज थिकनेस ऑफ कॉन्टिनेंट, डरो मत मुझसे, मैं सींग है क्या मेरे? देखो मेरी क्लास में ना बच्चे, पहली चीज डरना नहीं है, आपको जो सवाल ना आए, समझ में ना आए, आपको वो पूछना भी है, और जब मैं आपसे पार्टिसिपेशन चाहूं तो पार्टिसिपेट भी कर, ठीक है? बड़े सिली सवाल पूछता हूं मैं तुमको, खतरनाक सवाल नहीं होते, बहुत आसान से, ठीक है? चलिए, सो हियर वी हैव the crustal thickness, average crustal thickness happened to be 35 kilometer. It is what? Continental crust. This is the average thickness. While the average thickness of oceanic crust is 5 to 8 kilometer. 5 to 8 kilometer. This is oceanic crust. But somewhere continental crust are thicker, much thicker, like more than 70 kilometer up to 100 kilometer. So somewhere on the earth's surface you will find this thickness is going beyond, say, for 100 kilometer, and it generally occurs below the folded mountain like Himalaya, Andes, Rockies, Alps, Caucasus, Taurus, Tian Shan, Kulnul. These are the folded mountain series. So if you see the crustal thickness below it, it is quite thicker. Like Himalaya has a crustal thickness more than 70 kilometer. And you all have this idea that Himalaya is on destructive plate boundary. And destructive plate boundary पे क्या होता है बच्चे? Volcanic eruption is characteristic feature. But in Himalaya there is no volcanic eruption. Why? Because of the crustal thickness. Volcanism only takes place when crust is broken and magma comes out. Magma ने कहा मुझे बाहर जाने दे, crust ने कहा नहीं जाने दूंगा, खत्म हो गई बात. So there is no volcano in Himalaya. Why? Because of crustal thickness. Acha, tell me, this upper crust is made up of Cl, silica, aluminium, and this is made up of Sema, silica, magnesium. If you see the density of upper crust, it is going to be 2.57 gram per cc, while the density of lower crust is 3 gram per cc. Which is going to have higher density? Lower crust. Fine. अच्छा, tell me, थोड़ा सा इसको सुधारना पड़ेगा, यहां से सुधार लेते हैं. Fine. Tell me, in case of oceanic crust, ये लिख लिया था ना, सियाल सीमा वगैरह लिख लिया था ना? नहीं? Okay. So in case of oceanic crust, upper crust is bigger, thicker or lower crust? Lower crust. So lower crust is thicker. That's why oceanic crust is denser as compared to continental crust. So oceanic crust is largely made up of, lower crust. So lower crust is in bigger contribution than upper crust. Is it okay? And then there is a discontinuity between upper crust and lower crust. What is the name of this discontinuity? Can anyone tell? There is a discontinuity. What is the meaning of discontinuity? Change in density. Okay? No, it is Conard discontinuity. It is Conard discontinuity. It is Conard discontinuity. What is the meaning of discontinuity? You have the idea that discontinuity is a sudden change in density. There is normalcy and अचानक से आप हाईवे पे जा रहे थे और speed breakers आ गए. So that is what discontinuity. Similarly, the body waves are traveling and there is a sudden change in density, and that is called as discontinuity, and it is what conurred discontinuity between upper crust and lower crust, between upper crust and lower crust. This is 2.57 gram per cc and this is 3 gram per cc. It is made up of silica aluminium, it is made up of silica magnesium. Then there is a part of mantle. इसके बाद तो mantle ही है, लेकिन some part of mantle is associated with crust. ये बहुत इंपॉर्टेंट बात बता रहा हूं जो सीखनी है आपको, क्योंकि बहुत लोग कंफ्यूज होते हैं. So this is what mantle have started from here, and this part of mantle is associated with the crust, and this part of mantle along with crust called as lithosphere. Okay, so what do you mean by lithosphere? Here it is lithosphere. So from upper surface to this part of mantle, this is your lithosphere. So lithosphere consists of upper crust, lower crust, as well as upper part of upper mantle. Upper part of upper mantle. Below this upper mantle, there is a part of upper mantle which is what? Plastic in nature, and that is called as asthenosphere. So you'll find asthenosphere over here. This is what? Asthenosphere. 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 And I told you asthenosphere, the zone which is called as powerhouse of earth. So this is asthenosphere. If you see the depth of asthenosphere from the surface, there is 400 kilometers. This is the depth of asthenosphere. Again, it is part of upper mantle. Fine. Okay, there is a discontinuity between crust and mantle which is called as Mohovisic discontinuity. So Moho discontinuity कहाँ पे होनी चाहिए? Crust और mantle के बीच में. So I'm just showing it over here, and if you appreciate this or not, you tell me. Just taking the white. Na? Is it visible? This is the Moho discontinuity. Moho discontinuity or Mohovisic discontinuity. Mohovisic discontinuity. Mohovisic discontinuity is between the crust and the mantle. Crust and the mantle. This discontinuity. Mohovisic discontinuity. Mohovisic discontinuity. Is it okay? The discontinuity between crust and mantle is Mohovisic discontinuity. It was discovered by this person, Italian seismologist, Mohovisic discontinuity. Then we have this asthenosphere. What is the characteristic of this asthenosphere? This asthenosphere is plastic in nature. Plastic in nature. बहुत सारे बच्चों को लगता है कि सर एस्थेनोस्फीयर लिक्विड है. नहीं बच्चे, इट इज प्लास्टिक इन नेचर. इट इज प्लास्टिक इन नेचर. And the density of asthenosphere happened to be 3.5 gram per cc. And the temperature of asthenosphere is 900 to 1200 degree centigrade. So this is going to be very high temperature. और इतने टेम्परेचर पे मेल्टिंग तो होगी और मैग्मा बनेगा. मैग्मा कहां बनता है बच्चे? एस्थेनोस्फीयर में. ठीक है. फॉर्मेशन ऑफ मैग्मा टेकिंग प्लेस इन एस्थेनोस्फीयर. अच्छा, एस्थेनोस्फीयर की खास बात, देयर आर सर्टेन प्लेसेस इन एस्थेनोस्फीयर, दे आर हैविंग enormously high temperature. Means higher than the normal. The normal temperature ranging on an average 1000 degrees centigrade. But there are certain places in asthenosphere, they happen to have 2000 degrees centigrade temperature. Enormously high temperature. So in asthenosphere, there are certain area which is known for very high temperature. These areas have been termed as hot spots. These areas are termed as hot spots. These hot spots are only 40 to 50 hot spots are there on entire Earth. Now, these hot spot is having very high temperature of the range, let's say 2000 degrees centigrade. These are the hot spots. These hot spots has another name. They are also called as mental plumes. Mental plumes. Why it is called as mental plumes? Because the mental rock plumes in form of magma under the influence of residual heat stored in outer core. Outer core पता ही है बच्चे बहुत ज्यादा टेम्परेचर पे. So this is what? Hot spot. Where it is present? In asthenosphere. These hot spots present in asthenosphere, they are called as hot spot. They are present in asthenosphere. They are not changing their place. ऊपर से crust आया और चला गया, but hot spots are stationary. They remain in asthenosphere for always. And there are 40 to 50 such hot spots are there. Some other day I will describe the hot spot. And very interesting phenomena of hot spot that our Deccan trap is because of diffusion of reunion hot spot. और reunion कितना दूर है आप देख रहे हो? Just see the east of Madagascar, you will find Reunion Island. और वहां से कितना दूर है हमारा Deccan trap? Somewhere in geological past, India was above the Reunion Island and there was continuous effusion of magma, and that's why Deccan Trap was formed. And then Indian plate moved, huge Indian Ocean was formed. So these hot spots are not changing their place. They remain in asthenosphere, but the lithospheric plate moves from one place to other place. You have seen in plate tectonics. Is it understandable? Who talked about this hot spot? Tuzo Wilson. James Tuzo Wilson or J.T. Wilson in 1963, he gave the concept of hot spot. Okay. बनते कैसे हैं बच्चे ये hot spot? असल में mental में there are conducting rock. They are more conducting as compared to other rock. And the heat which is in outer core get conducted through these conducting rock to asthenosphere, and that's why the rock of the mantle get melted and comes in form of mantle plume or mushrooming magma. Is it okay? So if you see the source of heat for these hot spot, it is from outer core. It is from outer core. This is your outer core. Okay. Outer core, it is having very high heat and it is at temperature, average temperature of outer core 4000 degrees centigrade. It is in liquid state, and from here there are conducting rocks in mantle, and that's why these heat get conducted and there is pluming of magma taking place in asthenosphere. This is the reason of hot spots. Is it understandable to everyone? Tell me. So mental plume, क्वेश्चन आया हुआ है मेंटल प्लूम पे, रिवाइज तो नहीं कर सकते बट हाँ आप अंदाजा होना चाहिए. फाइन. अगेन दिस mental can be divided into two. There is upper mental and lower mental. This is what? Upper mental. Here it is lower mental. Upper mental and lower mental. अपर मेंटल में पार्ट ऑफ लिथोस्फीयर भी है, एस्थेनोस्फीयर भी है और अपर मेंटल भी. इफ यू सी द अपर मेंटल यू विल फाइंड दैट हियर द चेंज ऑफ डेंसिटी इज 3.5 ग्राम per cc to 5.5 gram per cc, and the temperature from 900 degree centigrade to 2200 degree centigrade. This is the change in temperature. Fine. Upper mental and lower mental. This is the zone at which outer core start is below 2900 kilometer. Is it okay? अब अपर मेंटल लोअर मेंटल में देख रहे हो आप डेंसिटी धीरे धीरे बढ़ रहा है. You will also find that there is temperature also increasing, and there is a discontinuity between upper mental and lower mental. And the name of this discontinuity कौन बताएगा? What is the name of this discontinuity? Rapidity. कोई बता ही नहीं रहा है. पीटी दे के आए हो ना? ये सब तो फिंगर टिप्स पे होने की जरूरत है. अब भूल के दिखाना. ये फिंगर टिप्स पे होने चाहिए बच्चे. रैपिडी. रैपिडी डिसकंटिन्यूटी. रैपिडी डिसकंटिन्यूटी बिटवीन अपर मेंटल, कहीं कहीं इसको आउटर मेंटल, इनर मेंटल भी कहते हैं. देयर आर मेनी मेंटल प्रॉब्लम. You can use anything. Outer mental, and here it is inner mental. Inner mental. ठीक है बच्चे. What is the change in density? Change in temperature. You understood. Most important part is what? Mental plume, and the source of heat is what? Outer core. Is it okay? Pluming of heat as well as magma through mantle from outer core to asthenosphere. These are hot spots. Then this is outer core, and there is a discontinuity between core and mantle. What is the name? ये तो बताना चाहिए आप. हाँ, गुटेनबर्ग. तो ऐसे क्यों सहम सहम के बता रहे हो? गुटेनबर्ग ने तो कायदे से बताया है ना बच्चे. So this is the discontinuity between core and mental, that is called as Gutenberg discontinuity. Gutenberg-Weichert discontinuity. Gutenberg-Weichert discontinuity. ठीक है बच्चे. Then there is outer core, and this outer core is in लिक्विड स्टेट. जब मैंने स्ट्रेटिफिकेशन ऑफ अर्थ पढ़ाया था क्लास में और इवोल्यूशन ऑफ एटमॉस्फेयर पढ़ाया था तो कुछ बताया था सिग्निफिकेंस ऑफ आउटर कोर. कोई बताएगा? क्या बताया था बच्चे? कि अर्थ के पास ग्रेविटी थी. देयर वाज ग्रेविटी विथ अर्थ, एंड अर्थ वाज गिवन द प्राइमोर्डियल एटमॉस्फेयर, बट दैट प्राइमोर्डियल एटमॉस्फेयर वाज स्ट्राइप्ड ऑफ because of the strong solar winds. And Earth realized that only gravity is not going to be there that can sustain atmosphere. और Earth के पास क्या करना था? उसे origin of life करानी थी, तो उसके पास stable atmosphere होना चाहिए था. Then what Earth did? Prelims fail हुई है Earth. याद रखिएगा. जब उसका primordial atmosphere ले लिया गया तो उसको समझ में आ गया it is not only the good coaching, good mentor, good notes and good book. Everything was there, gravity was there with Earth, but it was not sufficient enough to protect the atmosphere. कुछ और चाहिए था, और वो कुछ और क्या था? मैग्नेटोस्फीयर. वो कुछ और क्या है आपके लिए? आंसर राइटिंग, स्किल डेवलपमेंट, राइटिंग द आंसर, and that too on your very hectic day of your life. And that too satiating the demand of those buddhas जिसने पेपर सेट किया है, they are giving good question, that too in time limit and that too in word limit. आसान है क्या? ये आसान नहीं था अर्थ के लिए भी. Earth started sustained fusion and sustained fusion gave the heavy elements. Heavy element start settling towards the center and the formation of core and outer core was there, and it is made up of iron and nickel. And because of high temperature, what happened? Outer core become in liquid state. Liquid state, and because the earth is rotating now, so the core is also churning. And if it is in liquid state, obviously there will be free electrons. At this 4000 degree centigrade temperature, elements are in its plasma form, ionic form. So there will be free electron. When the core is rotating, outer core is churning, electrons are also moving. And movement of electron constitute electricity. And wherever there is electricity, there will be electromagnetic induction, hence magnetic field. So earth have developed magnetic field, magnetism, because of churning of outer core. Although the core is also participated, but churning of outer core was the major event that have taken place, and that have given the magnetosphere of earth, that gave the additional shield to our atmosphere, to primitive atmosphere. Primitive atmosphere stabilized, then chemical reaction have taken place and there was origin of life and diversification of life. तब जाके हम आए, शुभ्रा, रंजन IAS और आप सब UPSC की तैयारी कर रहे थे. तो इतना बड़ा महात्म्य है इसका. ना ये होता तो हम ना होते. समझ में आया? सिग्निफिकेंस ऑफ आउटर कोर, एक क्वेश्चन ये बन सकता है. इंटीरियर ऑफ अर्थ, व्हाट इज द सिग्निफिकेंस ऑफ आउटर कोर? So if you are writing significance of outer core, must write the magnetosphere, stability in atmosphere, origin of life, diversification of life. Because only gravity is not responsible to bring this atmosphere here. So although I am discussing the interior of earth, but I am talking about so many questions that can be cropped up from this particular topic. है ना? If I put this question, discuss the role of outer core in origin of life, है ना? अच्छा सा सवाल. Outer core का role in origin of life, can you write it? बड़ा छोटा सा 150 वर्ड का डिमांड क्वेश्चन है, लिख लो. क्वेश्चन please take down. Discuss the role of outer core in the origin of life. अब ये सवाल आते ही आधे लोगों के पैरों तले जमीन खिसक जाएगी. कहेंगे ये ज्योग्राफी का है, ये बायोलॉजी का है, साइंस है. ये कॉन्सेप्ट है बच्चे. क्या कॉन्सेप्ट है? बता दे रहा हूं. अर्थ वॉज हैविंग द प्राइमोर्डियल एटमॉस्फेयर, ठीक है, एंड व्हेन द स्ट्रॉन्ग सोलर विंड केम ओवर देयर, they have striped off this primordial atmosphere. This was primordial atmosphere. What is it? Strong solar wind. Despite of gravity. Gravity लेके कुछ नहीं होगा सर. आंसर राइटिंग नहीं होगी ना तो ग्रेविटी कुछ नहीं करेगा. आप समझ रहे मैं क्या कहना चाह रहा हूं? गुड नोट्स, गुड बुक्स, गुड मेंटर, मेक सेंस, बट मैक्सिमम थिंग इज व्हाट योर आंसर राइटिंग. अभी बैठना है और मीन्स होने के पहले तक बैठना है और एक ही काम करना है. जितना अच्छा लिखेंगे उतने अच्छे नंबर आएंगे. ठीक है? रिवाइज इट, राइट, गो फॉर द वेरियस टेस्ट. जितने टेस्ट आप देते हो ना, जितने आंसर लिखोगे, सच बता रहे हैं, थीम तो वही है ना बच्चे, थीम तो थोड़ी बदलेंगे. थीम्स आर जस्ट योर सिलेबस. टेक डाउन एज मच आंसर एज यू कैन. and get it evaluated. And I'm ready for it. Whosoever is here, I'm ready for it. Whatever you are going to write, I will evaluate personally and I will guide you personally. But आपकी तरफ से वो चीज आनी चाहिए. ठीक है बच्चे? तो क्या हुआ? This was a strong solar wind. This primordial atmosphere was taken away. Then there was sustained fusion reaction. Sustained fusion reaction and heavy elements were formed. Sustained fusion में क्या हुआ बच्चे? Hydrogen changes into helium, helium into other heavy element like carbon, oxygen, nitrogen, phosphorus, potassium, sodium, so on so forth, iron, nickel, so on so forth, cobalt, uranium, etc. This is what sustained fusion reaction. Same reaction have taken place in entire universe in order to create all these elements. And what happened when this was formed? They are heavy and the earth was rotating. तो क्या हुआ? Centrifugal force, centripetal force के कारण they start accumulating near the center. और center पे गए तो इन्होंने क्या बना दिया? They have created core as well as outer core. There was creation of core and outer core. And you know this core is in which state? Liquid state. It is in liquid state, core is solid state, and your earth is rotating from west to east, and due to it there is churning of outer core, and this led to formation of electric current. Hence there is magnetism around the earth. So magnetism around the earth was developed, and this magnetism lead to another shield, another kind of protection. And what it did? जो solar winds आ रहे थे ना, they are going to strike, they get diverted towards pole. अब pole की तरफ divert हुए and they have find the way into the space. It is not going to much affect the earth atmosphere. Now earth evolved another atmosphere which is called as primitive atmosphere. Primitive atmosphere. ठीक है बच्चे? अब ये प्रिमिटिव एटमॉस्फेयर अर्थ पे स्टेबली रह सकता था, तो वहां केमिकल रिएक्शंस हुए. देयर वेर केमिकल रिएक्शन एंड दैट लेड टू ओरिजिन ऑफ लाइफ. So this was the role played by outer core in stabilizing the primitive atmosphere as well as chemical reaction which is responsible for origin of life, chemosynthetic origin of life. तो है ना रोल बड़ा? It's a role played by outer core. So I talked about the answer. This is the question for you. Please do read and take down. And this is the very basic question from your NCERT. कहीं और से नहीं लाया मैं. It is already mentioned in your NCERT, stratification of earth, isn't it? So please mark it important. इसको भी important लगा लो, है ना? लोगों को लगेगा ये बायोलॉजी का क्वेश्चन आ गया. It is question from geography. चलो, let's come to the original topic, that is interior of earth. So this is outer core. As we know, this outer core extending from 2900 kilometer to 5150 kilometer. It is made up of Nephe, that is nickel and iron. More will be iron, and if you see the density, it has a change from 10.5 gram per cc to 11.5 gram per cc, and there is a change in temperature from 4000 degree centigrade to 4500 degree centigrade. 4500 degree centigrade. Okay. Role of outer core, churning of outer core, churning of outer core, giving the magnetism around the earth. Although the core is also responsible, but the bigger chunk given by the outer. Fine. And इसके बाद क्या है बच्चे? इसके बाद है core. There is core. Core, innermost part of Earth up to the center from 5150 to the 6378 kilometer. This is the core. Fine. Here it is the core. And if you see the core temperature, average temperature 5300 degrees centigrade, made up of iron as well as nickel, and the density is 13 gram per cc. This is going to be very high density, 13 gram per cc. And very important thing is that core, despite of this much temperature, is in solid state. It is in solid state. Despite of very high temperature, it is in solid state. Is it okay? आपके मन में एक सवाल आना चाहिए कि सॉलिड स्टेट में क्यों? उससे पहले जान लें, यहां पे एक डिसकंटिन्यूटी है. क्या नाम है इस डिसकंटिन्यूटी का? लेहमैन डिसकंटिन्यूटी. लेहमैन discontinuity. This is Lehman discontinuity. Lehman discontinuity. Core is solid. Core is solid despite of 5300 degrees centigrade temperature. It's a genuine question at this much high temperature. Why core is solid? Why liquid outer core? तो हाई टेम्परेचर आउटर कोर का लिक्विड होना इज व्हाट जनरल थिंग ना, बट कोर इज गोइंग टू हैव सुपर इनकम्बेंट प्रेशर ऑफ ओवरलाइंग रॉक, very high pressure of overlying rock. And you all have this idea. Let me explain a little bit so that you have the understanding of solid, liquid and gas. What is solid? When the molecules are placed closest, isn't it? This is what solid. That means intermolecular space is minimum. If any substance is there, intermolecular space is minimum, it will be in solid state. That's why you will find that solid has definite shape, definite size, definite volume. होता है ना? Definite shape, size and volume. And if there is a liquid, there is intermolecular space little bit higher. तो उनके बीच में जो intermolecular attraction है वो भी कम होगा. तो they have definite volume but they can take different shape, है ना? और गैस क्या है? ये बिल्कुल इनको कोई फर्क ही नहीं, दूर दूर है. The intermolecular space is massive and there is less intermolecular attraction. That's why they don't have any shape, any size, and they can be fit in all the volume. Okay, that means what makes you solid? When the intermolecular space is minimum. So despite of 5300 degrees centigrade temperature, core also want to enjoy the life, want to go to cinema, want to meet with friend, chill out. But core has some superincumbent pressure. That is UPSC mains. And there is no other option available to the core rather to be solid. So despite of 5300 degrees centigrade temperature, core has superincumbent gravity, superincumbent pressure. Core wants to be in liquid state. Anything can be in liquid state at this much high temperature, but because of superincumbent gravity, the molecules are packed closely that core has no other option rather to be in solid state. That's why core is in solid state. Are you getting my point? और आपको भी सॉलिड स्टेट में ही रहना है और कोई ऑप्शन नहीं है बस इन कुछ महीने, फिर तो बहुत सारे ऑप्शन है ना. सो दिस इज ऑल अबाउट द एक्सप्लेनेशन ऑफ interior of earth. Everything which is part of interior I have explained for general studies perspective. So do read and find out. Are you able to write question? Shall I give some question on interior of earth? Pakka. Although I have given all those questions which is related with interior of earth. So discuss the observations and findings that gave the idea of core and outer core. Core and outer core. ठीक है बच्चे, तो ये लिख सकते हैं, वही शैडो जोन पे ही इशारा है. आर यू गेटिंग माई पॉइंट कि हाउ दे कैन पुट क्वेश्चन एंड द सेम आंसर विल बी देयर. मीन्स आंसर इज नॉट सेम, लैंग्वेज इज डिफरेंट. तो यूपीएससी क्या करती है बच्चे, वो आपको सूजी दे देती है और फिर कहती है कि मेरा मन है हलवा खाने का. UPSC give you the suji through the teachers and then they demand I will go for halwa one day, another day I want uttapam. Raw material is same but recipe is different. If you understand this recipe, आप answer writing कर लो. Are you getting my point? The same raw material has to be allocated according to the demand of the question. Then you can write it. Is it okay to everyone? So this is the end of today's topic. Let's find out some more topic which is relevant for your examination. ठीक है ना, आपको कोई दिक्कत तो नहीं, अंडरस्टैंडिंग में प्रॉब्लम तो नहीं आ रही? Is it okay? Shall we move further? Okay. So there is one topic that is continental drift theory. Continental drift theory and evidences in support of it. They can give you major question upon it. It is also important. So let me explain this continental drift theory. Although in your general studies section you have seen that this continental drift theory was given by Alfred Wegener in the year 1912. लेकिन कहानी इससे थोड़ी पुरानी है, थोड़ी पुरानी और बहुत पुरानी. As an idea, if you see this continental drift, it was not a new thing. Way back in 1596, Abraham Ortelius have given this idea about the drift. Means as an idea, he was a cartographer, he made a map of North America, means America, Europe and Africa together. Okay, according to his idea that all the continents were together. Fine. In 1910, a fellow whose name is F.B. Teller, he challenged the paradigm of his time. What is the meaning of paradigm? Anything which is not debatable at all. Everyone is accepting. So F.B. Taylor challenged contraction theory. Contraction theory. ठीक है बच्चे? एफबी टेलर्स से पहले कॉन्ट्रैक्शन थियरी वाज अ पैराडाइम. इट वाज अ पैराडाइम. It was a paradigm. No one was questioning this theory. Everyone except कि अच्छा contraction ही हुआ होगा. डिटेल करूं या आप याद है आपको contraction theory? You have the idea of contraction theory? No idea? Okay. How the continents as well as ocean were originated on the Earth's surface. The contraction theory talks about that. ठीक है. क्या कहता है कॉन्ट्रैक्शन थियरी बच्चे? पहले यहीं से शुरुआत करते हैं, थोड़ा और पहले चलते हैं. कॉन्ट्रैक्शन थियरी कहता है बच्चे कि दिस अर्थ वाज अ हॉट बॉल एंड स्लोली एंड ग्रेजुअली इट गेट कूल्ड. कूलिंग हुई, डीगैसिंग हुई, देयर वाज फॉर्मेशन ऑफ एटमॉस्फेयर, स्ट्रेटिफिकेशन, इट वाज गोइंग ऑन. सो दिस क्रस्ट गेट कूल्ड and due to cooling what happened? There was contraction. Cooling followed by contraction. Is it okay? And this contraction is not homogeneous. Not homogeneous. This contraction was not homogeneous and there was undulation developed, and this undulation led to formation of, means there will be some part that get uplifted and there are some part that get depressed. The uplifted part become continents. Uplifted part become continents and the depressed part become basins where the water filled inside and it become ocean basin. This is what? Ocean basin. Okay. So how the continent and ocean basin were generated? This is the theory that talks about continents and ocean basin, the contraction theory. Okay, so it is just because of the cooling of the crust followed by contraction, and this contraction was not homogeneous. There was some mineral that have contracted more and created the depression, and there was some mineral which is contracted less, that they have created elevation. Elevated part become continent and depressed part become ocean basin. Continent and ocean basin, they are called as first order landforms. They are called as first order landforms. So, to understand the landform development, this theory has been proposed. Landform का मतलब whatever we are watching on the earth crust, mountain, plateau, plain, continent, ocean, these are the landform. First order, second order, third order landforms are there. तो detail class में हम लोग करते हैं. फिलहाल यहाँ you understand the contraction theory. This contraction theory was a paradigm. कि every landform which is created on the earth's surface is due to contraction, and the continents have elevated part. On the continents there are mountains, and that is also because of contraction. This was the theory which was paradigm. Paradigm matlab there was no debate against it. But in 1912, this person, F.B. Teller, who was American geomorphologist. He was an American geomorphologist. He challenged the contraction theory. He was working on tertiary folded mountain. He was working on tertiary folded mountain. टर्शरी फोल्डेड माउंटेन पे ये काम कर रहे थे. ठीक है बच्चे. टर्शरी फोल्डेड माउंटेन वो एल्पाइन माउंटेन भी कहते हैं, आल्प्स लाइक माउंटेन, एल्पाइन माउंटेन. क्यों? क्योंकि ऊंचाई पे काफी ऊंचे हैं. दे आर लॉफ्टीएस्ट ऑफ ऑल माउंटेन सीरीज इन द वर्ल्ड, एंड वंस यू मूव अप यू विल फाइंड देयर इज अ स्नो लाइन बियॉन्ड व्हिच यू विल फाइंड everything is frozen. That's why alpine climate is there, and that's why you happen to have alpine mountain, Alps like mountain. Is it okay? So he was working on tertiary folded mountain. देखो अभी मैं थियरी नहीं पढ़ा रहा, अभी मैं वो बातें सिखा रहा हूं जो कि माइलस्टोन है, जिसको आपको जानना चाहिए, जो कि पंच है. When you write all these things now, you will get good marks. Pangea Panthalsa, everyone is going to do. There was a landmass Pangea surrounded by Panthalsa, Laurasia, Gondwana, broken, and this. Everyone will talk about that. But those milestones from where the change was there, it is not going to be everyone's cup of tea. ये वही करेगा जिसने किताब पढ़ी है, वो नहीं करेगा जिसने नोट्स पढ़ा है. आर यू गेटिंग माय पॉइंट? तो नोट्स में आपको पेंजिया पैंथाल्सा है, लेकिन व्हाट बुक विल टेल यू द एंटायर स्टोरी. इज इट ओके? सो he was observing tertiary folded mountain. And what is the observation? Let me show you the observation. For that, we require a world map. Shall we go for drawing it? आप सब भी बनाओ सर world map within 10 seconds, 15 seconds. So this is your world map. What to remember? The most important thing, that equator must cross like this. It should not cross India. And Tropic of Capricorn should cross South America, Africa, as well as Australia. And Tropic of Cancer is like this, and this is the position. If you are moving like that, so you happen to have world map. नहीं पता चला अफ्रीका से तीनों ना गुजर रहे हो, एक निकल गया नीचे से. ऑस्ट्रेलिया वेट ही करता रह गया, यार कैप्रिकॉर्न तो गुजार दो, और आपने ऐसे मैप बनाए, और इंडिया के ऊपर से जा रहा है ट्रॉपिक ऑफ कैंसर. सो यू हैव टू अंडरस्टैंड दिस मच व्हाइल यू आर ड्राइंग द मैप. इज इट ओके? इट इज थीमेटिक मैप. तो हो सकता है आपने बहुत अच्छा मैप ना बनाया हो, बट it should represent like the continent. And map should be good because it is your product. You are selling the product to the examiner. If you are selling a bad packaging product, आप ही को मिले, तो how you will feel? If well packaged product is in front of you, then you will go gaga, isn't it? Okay, fine, this is good. So when you draw a map in a beautiful way, it will show the effort which you are putting over there. And if you are draw a map like, it will show that you are casual. And casual effort is not at all appreciated in this particular exam. So work upon it. There is no shortcut. आपको बनाना पड़ेगा और कई बार बनाना पड़ेगा. Then only you happen to have the acumen to draw it, and that too within time. If you see this North America part, you will find that there is Rockies mountain series over here, and Andes. This is Rockies. Rockies mountain in North America, Andes mountain in South America. Okay, if you see the extent of Andes and Rockies, what is the extent? North to south या east to west? Extension of Rockies and Andes in which direction? Tell me. नॉर्थ टू साउथ? नहीं पता? अरे बेटे ये तो पता है ना, इधर नॉर्थ, इधर साउथ, इधर ईस्ट, इधर वेस्ट. तो दिस इज नॉर्थ, दिस इज साउथ. सो जनरल एक्सटेंट इज फ्रॉम नॉर्थ टू साउथ. देन वी हैव टर्शियरी फोल्डेड माउंटेन इन यूरेशिया, एंड वी हैपन टू हैव सो मेनी, लाइक देयर इज अ माउंटेन हिमालय, Himalaya, Aracanioma. This is the mountain in India. This is Himalaya, Aracanioma. We have Karakoram. We have Pulnul. We have Hindu Kush, Zagros, Taurus, Caucasus, Alps. Okay. We have also some mountain series over like Suleiman, Kirtha. So these are the tertiary folded mountain. Here it is Alps, Caucasus, Taurus. There is Carpathian also, Zagros, Hindu Kush, Himalaya. All are called as tertiary folded mountain. What is the extent of these tertiary folded mountain of Eurasia? They are extended from west to east. West to east. F.B. Taylor was actually studying these tertiary folded mountain, and he concluded if these tertiary folded mountain were the result of contraction, so they should be either in north-south direction or east-west direction. They should not like one is in east-west, another one is north-south. If the contraction is there, only responsible for landform development, certainly the extension should be same. But extension is different. And this extension difference is actually telling some other story. And the other story is what? Continents were drifted. So his observation, F.B. Taylor's observation for the first time challenged contraction theory. And he gave his idea that continents were drifted under the forces which were tidal force as well as polar fleeing force. Is it okay? And then in 2 years, Alfred Wegener gave this theory of continental drift theory. It is the extension of F.B. Taylor's idea. ठीक है बच्चे? Are you getting my point? Continents were drifted. It is not because of only contraction. If contraction have taken place, either it is east-west or it should be north-south. It is not like at one continent you happen to have north-south extension. Another same mountain series, orogeny is of same time, is going to have different extension. That means it is not only the contraction, something else happened. Are you getting my point? Fine. फिर क्या हुआ बच्चे? फिर F.B. टेलर के ऑब्जर्वेशन के अलावा एल्फ्रेड वैगनर वाज आल्सो ग्रेट ऑब्जर्वर. एल्फ्रेड वैगनर, he was a German environmentalist. He was a German environmentalist and he was working on paleo glaciated landforms and paleo environment. Paleo environment, paleo, that means something related with past, fossils, something like that, geological past. So he was working on paleoclimatic data, paleo environment, paleoglaciated landform, paleofossils. And he observed something which was point of no return, that contraction happened. And he saw glaciated landforms. Glaciated landforms. In those areas, glaciated landform are glacier deposits from those areas which is immune from glacier. इसका क्या मतलब है बच्चे? आपका ये अर्थ सरफेस है ना, दिस इज अर्थ, here it is equator, tropic of Cancer, tropic of Capricorn. This is called as tropics, torrid zone. Even in ice age there is no glacier. यहां ग्लेशियर नहीं आ सकते. ग्लेशियर टेम्परेट पोलर में तो रहते ही हैं, टेम्परेट रीजन पूरा फ्रोजन हो जाएगा, बट इक्वेटोरियल रीजन और ट्रॉपिकल रीजन में देयर विल नॉट बी ग्लेशियर, ग्लेशियर नहीं है. एंड इफ यू आर गेटिंग अ ग्लेशिएटेड लैंडफॉर्म near, say for example, Tropic of Cancer. This is the place where you get the glaciated landform. So what will be your take? You have two options. Either Hulk brought the glacier and he did like this and created landform. But in 1910 there was no Marvel as well as Hulk. Or these land masses were somewhere in geological past where glacier can naturally occur. That means whatever is today's position, it was not the geological past position. This was somewhere near the South Pole. This is the only possibility. So, this person's observation of glaciated landform and glacier deposits, that is called as stellites, is also speaking same truth that was observed by F.B. Taylor. Is it okay? So landform from those area which is immune from glacier, and that is what tropical region. Near equator you are getting landform. I have just given you example of India. It was observed from South America, Africa, isn't it? Australia. So landform were observed from those areas where glaciers are not possible. It can only be possible when the land was together somewhere near the South Pole, isn't it? So all these observations become the basics to develop a new theory that have not only challenged the contraction theory, but dethroned this theory from the paradigm chairmanship. Dethroned. कहा कि भाई अब हमारा चलेगा. And then he explained this theory, and that is what? अब आ जाइए Pangea Panthalsa पे. He explained this theory in 1912. He said there was a huge landmass which was Pangea, surrounded by water body Panthalsa. And what happened? They were together 300 million years ago. And then there was split and two land masses were created. Northern landmass that is called as बताओ भाई, यूरेशिया, क्या कहते हैं, अंगारा लैंड, लॉरेशिया and Gondwana, and in between them there was an ocean created. What is the name of that ocean? Tethys Sea. And there was further split, and a split was Laurasia divided into North America, Eurasia and Arctics, while Gondwana divided into South America, Africa, then from Africa Antarctica was separated, then Australia was separated, and then India and Madagascar was separated. So these were the land masses which were formed. This was separation, and almost this happened by 150 million years ago. So these all story undergoing like this, and this is the condition. Ultimately, these were the land masses. Now what? There are certain forces which is responsible for movement, and they have some basic principle over which they have given this theory. And the first statement was Sial floats over Seema. अभी आपने देखा Sial, Seema and lithosphere floats over asthenosphere. At that very time it was erroneous. ठीक है बच्चे? So the theory is erroneous. It is not based on scientific ground. There are many faults, but the observations are point of no return. ये पत्थर पे लकीर थे. Observation like tertiary folded mountain, observation like glaciated landform, observation like fossil deposit, placer deposit, rock strata, coal deposits, evidence from magnetism, these all are telling same story that continents were drifted, isn't it? So these continents were formed and there were forces. First thing, forces, and the first force was polar fleeing force. Polar fleeing force. ये कैसे बना बच्चे? This is the earth which is rotating on its axis. So anything near the pole will feel a centrifugal drag, and it brings towards equator. So there is equatorward movement, because of centrifugal force, and this centrifugal force is attributed to rotation of earth. So it is due to rotation of earth, centrifugal force, and this centrifugal force tend to move the landmass towards the equator. Is it okay? And the second force is tidal force. Tidal force, that is force of attraction of sun plus moon. And this tidal force is responsible for westward movement. Tidal force is responsible for westward movement because चाहे moon हो या sun, earth के rotation के कारण it is always moving, means dragging anything and everything on the earth towards west. Tides आते हैं, it is moving towards west. क्यों? 24 hour में earth is going to rotate, but the moon remain behind. That's why the tidal force is always directed towards west. So anything under the influence of tidal force is moving towards west from the east. Is it okay? So that's why there was westward movement. Then they explained the formation of Eurasian mountain as well as Andes and Rockies. They said कि North America as well as South America, they were dragged towards west. And due to this, there was formation of Andes and Rockies. They were dragged towards west. Under the influence of tidal force. They said the tidal force is responsible for westward movement. And because they have also one statement in the initial that Sial floats over Sima. Sial floats over Sima. It is erroneous ना? Sial floats over Sima. अभी गलत है ये, है ना? You all have this idea. Sial, Sima, and part of upper mantle floating over asthenosphere. So this is what Sial, and here it is Sima, and under the influence of tidal force, what happened? This is tidal force. This tidal force taking the Sial west, and that's why there is huge friction generated at the interface. So frictional force generated. And when this friction generated over here, the western margin of North America and South America get folded. Western margin of North America as well as South America get folded, get folded in form of parallel mountain series that we call Cordillera, Rockies as well as Andes. So how these Rockies as well as Andes, this is Rocky, Andes mountain series, were formed at western margin, try to see west margin. It is because of tidal force of sun and moon. Sial floating over Sima, there is a frictional force generated at the interface. Due to that, this western margin get folded. The eastern margin is not folded. If you put a page and try to move it and keep it at one side, where you have created the block, you will find the folding is taking place. Is it okay? So this is how the folding have taken place. Westward movement of North American and South American landmass have gave rise to formation of Andes and Rockies. Is it okay? Then he said, he under the influence of polar fleeing force, under the influence of polar fleeing force, there was a movement of North America, Eurasia, Africa. This is Africa. I'm just drawing here. Here it is Africa. India. This is Indian landmass, and here it is Australia. There was a movement, reduce it. There was a movement, and it is what? Equatorward movement. It is moving like this under the influence of polar fleeing force. What happened? They are moving towards equator. And what happened? When they collide, this was a Tethys geosyncline, or Tethys Sea, and there was lot of sediment over there. And when both collided over there, and what happened? There was orogeny of tertiary folded mountain of Eurasia. And once there is a collision, what will be the outcome? The outcome is this. This was the outcome. So you'll find that equatorward movement, because of under the influence of polar fleeing force, there was formation of tertiary folded mountain of Eurasia from east to west, isn't it? And westward movement and Sial floating over Sima, frictional force have given the orogeny of Rockies and Andes. This was their take. अब जब कभी आप इस तरह की थियरी बता दोगे तो उसमें कमियां दिखेंगी, and there were lot of discrepancies, like are the forces which you talked about capable enough to cause such drift? तो अब they are malnourished. Why not moon is dragging us? If this is the power of moon as well as sun's tidal force, so why not they are doing so right now? नहीं पता. Are you getting? Then it was estimated that if the sun's and moon tidal force is going to increase by 10,000 crore times more, then only they can cause this much drift. It was not the case. And they said Sial float over Sima, it is erroneous or not? Today you have seen that lithosphere floats over asthenosphere. So it was erroneous statement. Further, why they moved westward only? Why not they moved westward? Why they moved equatorward and they are only westward? These are some question, genuine question, which is what not explained by the continental drift theory. It was not explained. But one thing was clear, the observation कि काला हिरण मरा, गोली चला के अपने से मर गया या किसी ने गोली मार, लेकिन काला हिरण तो मरा हुआ है, जिसको मरना नहीं था। अब उसने आत्महत्या की कि नहीं, ये पोर्ट ढूंढ रहा। लेकिन व्हाट इज राइट, द ऑब्जर्वेशन, tertiary folded mountain have extend like this and placer deposits, fossil evidence, they are recovered from those area which happen to be, means which telling same story that continents were together somewhere in geological past, isn't it? So these are the demerits which I talked about. The force responsible for such drift was not sufficient enough, it was not well explained, and there are certain erroneous thing like Sial floating over Seema. This assumption is wrong. Further, if the force has to be increased by 10,000 crore times, then only they can cause this much drift. And the forces as well as the mechanism was just to satiate, just to satisfy their finding, but not the real finding. But above all, there are certain evidence that is also going to speak same story. And what were those evidence? Shall I go for it? बोर तो नहीं हुए? पक्का? तो ये जो फोर्स इन्होंने बताए थे ना बच्चे, वो फोर्सेस सही नहीं थे। ये मैं बीच में कहीं बनाने लग गया ना, ठीक है। सो व्हाट वेयर द एविडेंसेस? एविडेंसेस में आप क्या पढ़ते हैं? पहला वाला लिख देते हैं जिग्स ऑफ इट, क्योंकि आप छोटे बच्चे थे, पजल खेल के आए हुए थे, तो आपको समझाने के लिए सबसे पहले लिख दिया। नाउ यू हैव प्लेड लॉट ऑफ पजल्स अपार्ट फ्रॉम पजल, तो आपने खेल लिया ना, अब बड़े हो गए हैं, तो इसी पॉइंट को पहले लिखा जाए। इज इट राइट? आंसर इज नो। ट्राई टू इंट्रोड्यूस द बेस्ट पॉइंट्स, बेस्ट पॉइंट लाइक प्लेसर डिपॉजिट। तो पहला क्या लिखेंगे बच्चे? मेरी बात समझ पाए कि नहीं? आप छोटे थे तो आपको सिंप्लीफाइड वर्जन पहले दिया गया, बट वंस यू आर राइटिंग इन योर मेंस, डोंट गो फॉर सर देखिए जिग्स ऑफ इट। नो, it is the most feeble evidence and there are many drawbacks. The stronger evidence should be first, like first one you can take placer deposit. Placer deposits, okay. Placer deposits were recovered from Ghana coast. Ghana is equatorial Africa, and this was the area from where you have seen the placer deposit. Placer deposit is nothing but the fine sediment of precious metal like gold. So there was a placer deposit. Placer deposit. Okay. Fine sediments of gold brought by river. दो चीजें हैं बच्चे, प्लेसर डिपॉजिट ब्रॉट बाय रिवर एंड दे आर द सेडिमेंट्स ऑफ गोल्ड। तो दो चीजें चाहिए हमें, एक तो रिवर चाहिए और गोल्ड बियरिंग रॉक्स चाहिए। When the gold bearing rocks were searched, gold bearing rocks, are gold seams. It were searched around this Ghana, there was no gold seam or gold bearing rock was recovered. But yes, almost 4,500 kilometer away from here. There was another continent, and there was a peninsula which is called as Sun Rock Peninsula. This is Brazil, where gold bearing rocks found. So gold rocks were recovered from here. These are what? Gold. सो ये कहानी क्या कहती है बच्चे कि गोल्ड रॉक यहाँ है, गोल्ड डिपॉजिट वहां है, देयर इज सम पाइपलाइन, तभी तो वहां पहुंचे होंगे. तो 4,500 किलोमीटर पाइपलाइन, नो पाइपलाइन इज देयर. दैट मीन्स समवेयर इन जियोलॉजिकल पास्ट बोथ वेयर टुगेदर. आ ही नहीं रहे पास, जाने देते, ऐसे थोड़ी आ जाएंगे. So this gold rocks are in Brazil, and placer deposits in Ghana is telling you the same story, that in geological past they were together. Okay. Then there was fossil deposits. Okay. Fossil deposits. Let's talk about fossil deposit. Shall we go for it? Okay. So there was fossil deposits. Let me draw the entire Gondwana together. Okay, you can understand this is South America, Africa, India, Madagascar, Antarctica, and here it is Australia. Okay. What was recovered? That there was fossils of a reptile that is called as Cynognathus, which were recovered from here. Reptiles, Cynognathus fossils were recovered from northern part of South America and northern part of Africa. This was what? Cynognathus. Cynognathus. This was the fossil, this was animal, reptile, 1.5 to 3 meter long reptile. It was discovered here. It was a reptile. Cynognathus. Then there was another fossil which were recovered from the southern part of Africa as well as South America, and this was Mesosaurus. It was Mesosaurus. Mesosaurus. Mesosaurus was also a fossil, a reptile. And the fossils were recovered from these two landmass. Then there was a fossils of Listosaurus, which were recovered from India as well as Madagascar and Antarctica. This was the fossil that is of Listosaurus. Listosaurus is also going to be reptile. It is also animal. So these fossils were prevalent on all the part. इतने दूर तक एनिमल का डिस्ट्रीब्यूशन नॉर्मली होता नहीं. एनिमल डिस्ट्रीब्यूशन इज नॉट टेकिंग प्लेस अप टू सच अ ह्यूज एक्सटेंट. इट इज क्वाइट इम्पॉसिबल. But the animal fossils were recovered from all these parts. Is telling what? Somewhere in geological past, the landmass were together. Because they have been separated by 4,500 kilometers of Atlantic Ocean, almost 4,000 kilometers of Indian Ocean, 12,000 kilometers of Pacific Ocean. Isn't it? They have been separated so far. Even then, these fossils were together. तो आपके मन में आएगा कि सर एनिमल हैं, जा सकते हैं. आर्कटिक टर्न्स वहां से चले आते हैं आर्कटिक रीजन से बर्ड्स, साइबेरियन सारस, है ना, ऑलिव रिडले टर्टल स्विम द इंटायर पैसिफिक रीचिंग टू गहिरमाथा एंड ऋषिकुल्या रिवर, गहिरमाथा कोस्ट एंड ऋषिकुल्या रिवर इन इंडिया, उड़ीसा. So why not they can travel this much? I can also say कि हाँ fine, ऐसा हो सकता है, because they can go for locomotion. But what about tree? Tree cannot go for locomotion. Tree cannot swim. And if you are getting tree fossil from entire Gondwana, so what will be your take? Somewhere in geological past they were together. And yes, there was a fossil of Glossopteris, which were recovered from entire Gondwana. Entire Gondwana. This was the fossil which was recovered. This is what Glossopteris. It was a fern. Fern are basically pteridophytes. Pteridophytes. They were recovered from entire Gondwana. They were recovered from South America, Africa, Madagascar, India, Antarctica and Australia. Such a huge distribution of plant at least cannot be possible until unless the land mass were. And these fossils are telling the truth. Okay, the land mass were together. Now they have moved. So once they put the question, he discussed the evidence, please discuss Glossopteris a little bit more. Why? Because it is going to be your punch. Animal can be distributed because they can locomote, but the trees or plants, they don't have locomotion, they are restricted. If their distribution is so much, that means the land is going to be together. Is it okay? So once you discuss the fossil, please emphasize Glossopteris. ठीक है, आगे चले बच्चे. What next? Next one is glaciated landform. Glaciated landform as well as glaciated deposits. These were located from those areas where the glaciers are not able to reach. Glaciers are not able to reach. These are the area immune from glacier. So if you see the 0 degree 23.5 degree north, this is 0 degree 23.5 degree south, it is going to be the tropics, and you find there are some glaciated landform that were recovered, then it is but obvious that all these land masses were together somewhere near the pole, because these area, even in ice age, no frozen land is there, no glacier is there. ठीक है, these area are immune from glacier. These area are immune from glacier. Even then you find delights over there, landform over there. So it is telling the same truth. Apart from it, there are many evidence. समय भी हो गया काफी ज्यादा, तो अगली क्लास भी है, तो इसके आगे कहानी कल देखते हैं. लिखेंगे कुछ, दो क्वेश्चन. क्वेश्चन इज, what is continental drift theory? Discuss the evidences in support of it. Discuss the evidences in support of it. Question number 2, इसको जरूर ट्राई करना, लिखने जा रहा हूं. Question number 2, what do you understand from continental drift theory? Discuss the observations that became point of no return in pursuit of development of theory development of theories. Okay, what do you understand from continental drift theory? Discuss the points of no return which were proved to be pivotal, that became point of no return in pursuit of development of theories. Both the questions are same. Will you go for same introduction or there is some different introduction? It is you to decide. कल लिख के लाओ तो फिर बात बनेगी. Take down and 200 words and do remember the 7 minutes. ठीक है? So shall I stop here? So कल मिलते हैं कुछ और important parts से. So we'll discuss.